I put 7 free AI coding models through the same 4 tests on one Mac. And the winner is not the model everyone keeps recommending. One community favorite found the bug I planted, explained it perfectly, and then wrote me an essay instead of fixing it. Another model that supposedly fits my machine took 17 minutes to do a 2-minute job. And one model swept every single test at full speed, and almost nobody talks about it. By the end of this video, you'll know exactly which free coding model to run on your machine, whether you have 8 gigabytes of memory or 64. Every number you're about to see came from a real test I ran this week, and I kept every receipt. First, why this month changed everything. On July 2nd, Poolside released Laguna XS 2.1, a 33 billion parameter coding model, free to download, that activates only 3 billion parameters at a time. On July 15, Mira Murati's Thinking Machines Lab shipped its first open model. And the Quen team's coder models have been climbing all summer. The trick behind all of them is the same. Mixture of experts, models with tiny active footprints, which means models that used to need a server rack now load on a laptop. But let me be honest with you upfront, because the community is honest about this too. The best local models today play at the level of the smaller cloud models, not the frontier ones. Nobody serious claims otherwise. The real question is different. How much coding ability can you actually get for $0 a month on the machine you already own? That question finally has a good answer. Here are the rules of the tournament. The machine is my MacBook Pro, an M4 Pro with 24 gigabytes of unified memory. Not a monster rig on purpose. It's the kind of machine you might actually have. Every model faces the same 4 tests at temperature 0, so nothing is left to luck. Test 1, I hand it a small project with 2 bugs I planted and the failing test log, and it has to return a fixed file. Test 2, I give it a written spec and grade the code against a hidden test suite it never sees. And before you ask, I check that the suite is fair. My own reference solution passes 7 out of 7. Test 3 is the one that separates 2026 models from last year's. The model gets 4 tools: list files, read file, write file, run tests. It has to find a bug it has never seen, fix it, and prove the fix completely on its own. And test 4 measures raw speed in tokens per second, using the exact counters from the runtime. Every transcript is saved. Let's climb the ladder. Tier 1, machines with 8 gigabytes of memory, 2 contenders, Quen 2.5 coder, 7B, the model every Reddit thread still recommends first, and Ornith 9B, the new agentic coding model that made noise in June. Quen came out fast, 46 tokens a second, and nailed the bug fix on the first try. On the hidden test suite, it scored 6 out of 7, missing only one edge case. It accepted a decimal number where the spec demanded a whole number. Close, but a miss is a miss. Ornith fixed the planted bugs too. But on the build from spec test, it did something I did not expect from a coding model. Its code actually included the exact whole number check that Quen missed. And then it shipped that same file with a literal placeholder still inside. A variable called path placeholder with a comment saying see below. There was nothing below. The code crashed on load, 7 errors. So after 2 tests, the 8 gigabyte a tier looked like a coin flip. Then came the tool test, and the coin flip ended. Here's what happened when I gave both models the 4 tools. Quen, 2.5 coder, understood the assignment. It even knew which tool to call first. But instead of speaking the tool protocol, it typed the tool call out as plain text, like writing the address on the envelope and never mailing it. The runtime just saw a message. Nothing executed. I even added a translator to my harness that parsed its text and ran the tools for it, and it still couldn't finish the job. Ornith, same tools, same prompt, called list files, read the code, spotted the inverted formula, wrote the fix, ran the tests, and reported done. 5 clean tool calls, all green. This is the single biggest divider in local coding models right now. It's not intelligence, it's whether the model can actually act. Every agentic editor, every coding assistant that edits files for you depends on this one skill. So on 8 gigabytes, the verdict writes itself. If you want a chat assistant, Quen is fine and fast. If you want a model that works on your code by itself, Ornith 9B is the smallest model that can. Tier 2, 16 gigabytes. This is where the tournament stop being close. The contenders. Devstral 24B, the model famous for its software engineering benchmark score, and gpt-oss S20B, OpenAI's open weights model, 14 gigabytes on disk. Devstral fixed the planted bugs, fine. But on the hidden suite, it scored 5 out of 7. And on the tool test, it did the most human thing I've ever watched a model do. It listed the files, read the code, found the bug correctly in 2 moves. And then it stopped and wrote me a paragraph explaining the bug. Never touched the file. Never ran the tests. Diagnosis without treatment at 15 tokens a second. gpt-oss S20B swept the board. Bug, fix, pass. Hidden suite. 7 out of 7. First model to do it. Tool loop. 5 calls. Found it. Fixed it. Proved it. Done. And it did all of that at 45 tokens a second. Basically the same speed as a model 1/3 its size. Remember that number because the next tier makes it matter. Tier 3, the heavyweights that fit in 24 to 32 gigabytes. Quen 3 Coder 30B, 19 gigabytes on disk. And the brand new Laguna XS from Poolside, 20 gigabytes. Both of these are genuinely smarter than everything below them. Quen 3 Coder swept all 4 tests. Laguna swept all 4 tests. On paper, a shared crown. Now, here's what the benchmark tables will never show you. On my 24 gigabyte Mac, Quen 3 Coder ran at 9 tokens a second. Laguna ran at 4 to 7. The build from spec task that GPT-oss finished in 36 seconds took Laguna 17 minutes. Same task, same machine. Both models technically fit in memory, but they're so close to the ceiling that the system starts spilling work back onto the CPU and everything slows to a crawl. That's the honest lesson of this whole experiment. Fits is not the same as usable. On a 32 gigabyte machine with room to breathe, these two are the smartest local coders you can run. And Quen 3 Coder would be my pick of the pair. On 24, the smaller model that sweeps at full speed beats the bigger model that crawls. Which brings us to the top of the ladder. Quen 3 Coder next. 80 billion parameters, only 3 billion active. This is the model the local AI community calls the king right now. Full disclosure, and this matters. Even compressed, it's a 52 gigabyte download. It cannot run on my 24 gigabyte Mac, and I won't pretend otherwise. So I tested its quality through its own hosted endpoint. Same 4 tests, same prompts, and I'm labeling every number from it as a hosted result. It passed everything. And on the tool test, it did something none of the local models did. 12 tool calls. It explored the whole project first, read the tests, then the code, made the fix, and ran the tests twice to be sure. That's not just passing, that's methodical. On the big unified memory Macs, community benchmarks show it running around 70 tokens a second. That is what your next memory upgrade actually buys you. Not a smarter autocomplete, a senior model that double checks its own work. So here is the whole ladder. One screen. Pick your budget. 8 gigabytes. Ornith 9B. If you want an agent, Quen 2.5 Coder if you just want fast answers. 16 gigabytes. gpt-oss 20B full stop. It swept every test at full speed and honestly, it embarrassed models above its weight class. 24 gigabytes my machine. Still gpt-oss 20B. The bigger models pass more elegantly but run 3 to 5 times slower, and 17-minute tasks are not a workflow. 32 gigabytes. Now, the heavyweights make sense. Qwen 3 Coder 30B with Laguna as the new challenger, worth watching. 64 gigabytes and up, Qwen 3 Coder next, the current king. And if you're keeping score against the cloud, the 16 gigabyte winner is free, private, works on an airplane, and costs exactly $0 a month, forever. Now, the honest part, because I test these things so you don't get burned, where local still loses. Speed of thought. The frontier cloud models are still faster and sharper on genuinely hard problems, and it's not close on the hardest ones. Breadth. When a task needs deep knowledge of an obscure framework, bigger models simply know more, and convenience. A cloud model never asks how much memory your laptop has. But here's where local wins, and these wins are real. Your code never leaves your machine. Not for training, not for logging, not for anyone. It works with no internet, on a plane, in a cafe with dead Wi-Fi, in a country where the API is blocked. It costs nothing per month, no matter how much you use it. And for the everyday 80% of coding work, fix this bug, write this function, explain this file. The gap has closed to the point where, most of the time, you honestly won't notice which one you're talking to. Want to try the winner tonight? 3 commands. Download Ollama from ollama.com. It's a normal installer. Then in your terminal, Ollama pull gpt-oss colon 20B. That's a 14 gigabyte download, so start it before dinner. Then Ollama run, same name, and you're talking to it. If you're on 8 gigabytes, pull Ornith 9B instead, 5.6 gigabytes. And one pro tip from my testing. Keep your other apps closed the first time you run it. These models want all the memory they can get, and you'll see the difference immediately. Real talk. 90% of you watching haven't subscribed. On Facebook, subscribe is the supporter button. That is what keeps the lights on here. On YouTube, it's free, and it tells the algorithm to send you more. Subscribe to support us. Everything from today is packaged for you. The full tier ladder with my pick at every memory size, the complete scorecard from all 4 tests, the exact setup commands, and the honest cheat sheet of when to use local versus cloud. It's free. Comment the word tier and I'll send it to you, or grab it at hyperautomationlabs.co/free/tier. If you're just getting started with Cloud Code, the 4 beginner guides are linked below the video. And I post the receipts from experiments like this on Instagram and Facebook between videos. A year ago, running a real coding model on a laptop was a party trick. This week, one of them swept my whole test suite at full speed for free. The cloud bill isn't dead. But for the first time, it's optional.